Good evening, all of you. So, this is the week 3, and in this session, we will solve the GATE previous year questions. So, let's start with the first question. In this question came in GATE 2013. The question says a settling tank in a wastewater treatment plant is designed for a surface overflow rate of 30 meter cube per day per meter square. Assume specific gravity of the sediment particle is 2.65, density of water is 1000 kg per meter cube, dynamic viscosity of water is 0.001 Newton second per meter square, and Stokes law is valid. The approximate minimum size of particle that would be completely removed is. So they have given four options. So basically, when in this question, first, am I audible?
Yes, audible.
Okay. So basically, in this question, when they are mentioning the approximate minimum size of particle that would be completely removed. So we know that when in terms of settling velocity, for so our approach will be for complete. So basically, for 100% removal, for 100% removal of particles, overflow rate should be less than or equal to the settling velocity. This is we know in question the overflow rate they have mentioned as surface of 30 meter cube per day meter square. So basically overflow rate they have mentioned at 30 meter cube per day meter square. So we have to convert this into 30 divided by 86400 so that we can get in terms of meter cube per meter square second. So the value will come out to be 3.47 into 10 raised to the power minus 4 meter cube per meter square second. Okay. So now we know the our overflow velocity. Knowing the overflow velocity, now we have to calculate the settling velocity. So we can write this as like that. Overflow rate should be equal to the settling velocity. So settling velocity formula is g d square diameter of the particle rho s minus rho w divided by 18 mu. So the value of overflow velocity which we calculate just now, we will keep it later. So now the question is asking about the approximate minimum size of particle. For the minimum size of particle, basically we have to calculate the diameter. So if we rearrange this equation, and so basically d will be equal to under root of 18 mu v by g rho s minus rho w. Okay, so if we have to write in terms of g, we will get like this. Okay, so now d should be greater than equal to 18 into, so dynamic viscosity, the value they have given as 0.001 0.001 into overflow velocity we also calculated, which is equals to 3.74 into 10 raised to power minus 4 entire under the square root. Now g we know value is 9.81 into, so g value they have given us 2.65. So 2.65 minus 1, if we take rho w outside, rho s by rho w will become g. So here it will be 1. So rho w here value will be 1000. Density of water is 1000 kg per meter cube. Okay. So now after substituting this, so d minimum will come out to be d should be come out to be 1.964 into 10 raised to 5 meter. Okay, so we got the d value, but here is the catch. The question in question the value is given in terms of mm. So whenever now we got in terms of meter, so we have to convert in terms of mm. So if we multiply it with 1000 in 10 to the power 3 mm, so it will be 1.964 into 10 to the power minus 2 mm. Okay, so now we can write it as 0.01964 mm. So basically d minimum is equal should be is equivalent to 0.02 mm. Okay, so the answer is B, option B. So is it clear? Is it clear? Okay. So since few students joined late, I will again repeat the entire question. The question basically says a settling tank in wastewater treatment plant is designed for a surface overflow rate of 30 meter cube per day meter square. Assume specific gravity of sediment particle is equal to 2.65. Density of water they are mentioned as 1000 kg per meter cube and the given the value of dynamic viscosity. And they are saying Stokes law is valid. The approximate minimum size of particle that would be completely removed is. So basically we know for 100% removal of particle, our overflow rate should be less than or equal to settling velocity. In the question, they have mentioned overflow rate as 30 meter cube per day meter square. So we have calculated this in terms of meter cube per meter square second. Okay, so now we know the overflow velocity. So this is overflow velocity. Okay, so overflow velocity now you know. Knowing this, then we some using this equation one. Now we were added. Now we'll go back to the equation one and we wrote the formula of settling velocity. Then we rearranged it so that we can get the value of diameter. After rearranging it, we added the value. We substituted the values. So after substituting, we got the value of d in terms of meter. But in the options, the answers are in the form of mm in millimeter. So then to calculate in terms of mm, we multiplied with 10 over 3. So then we got the value d minimum will be 0.02 mm. I hope it is clear. So now next question. So next question says a suspension sand-like particle in water with particles of diameter 0.1 mm and below is flowing into a settling tank at 0.1 meter cube per second. Assume G is equal to 9.81 meter per second square. Specific gravity of particle is 2.65. Kinematic viscosity of water is 1.0105 into 10 to minus 2 centimeter square per second. The minimum surface area required for the settling tank to remove particles of size 0.06 mm and above with 100% efficiency. So this question came in GATE 2014 in set 2. Now again they are talking about 100% efficiency. So we know for 100% efficiency, overflow rate should be less than or equal to settling velocity of particle. Okay. So now overflow rate basically we write in terms of Q by A should be less than equals to settling velocity. Now they are talking about minimum surface area. So the question is asking the minimum surface area. What should be the minimum surface area? To get the minimum surface area, we can write this as A Q by Vs. So this only I rearranged. A I kept it here and Vs came to denominator. So A should be greater than equal to Q by Vs. Now settling velocity formula is gamma s minus gamma w d square by 18 mu. So you can write this equation also as gs minus 1 rho w d square by 18 mu. You can so gs minus 1. So in question they have given kinematic viscosity. If you look at, they have mentioned kinematic viscosity. For kinematic viscosity it will be now. So this will be now kinematic viscosity. So Vs is equals to Gs minus 1 d square G d square basically it will be. So here there will be G, it will come. So d square by G. Okay. So now we got the settling velocity. So once we substitute the values, Vs is equals to 2.65 minus 1 into 9.81 small gravity and 0.06 into 10 to the minus 3 whole square. So we substitute the value of d, which is given in the question as 0.10. Uh, so the d particle size will be this one, 0.06 mm. Okay, so since it is given in mm, we converted in terms of meter. So that's why I wrote 0.06 into 10 to the minus 3 whole square divided by 18 into kinematic viscosity value they have given as 1.0105 into 10 to the minus 2 centimeter square. So I will write convert it in terms of meter square. So into 1.0105 into 10 raised to the power minus 6 meter square per second, and this is meters per second. Okay. So now after calculating the Vs value will come out to be 3.2036 into 10 to the minus 3 meter per second. This we got a settling velocity, but we have to calculate the minimum surface area. For minimum surface area, we have to use this equation. Okay, so A is greater than equal to Q upon Vs. Now, if you add the value of Q and Vs, A less than equal to value of Q. Value of Q in question is given as 0.1 meter cube per second. Okay, so 0.1 meter cube per second divided by 3.2036 into 10 to the minus 3. So now after calculating, the A will come out to be 31.214 meter square. Okay, so is it clear? Is it clear?
Yes, sir.
Okay. So basically in this question what we have done, we just using the previous concept, that is for 100% efficiency overflow rate shall be less than equal to settling velocity of particle. So now we have this equation. So basically in this we have calculated the value of Vs, then in it is given Q, Q value is given, Vs we have calculated, and then we have calculated the area. Okay, so Vs we calculated with the general Stokes law equation. Using that Vs, once we calculated the Vs 3.2036 into 10 to the minus 3, we substituted in this equation, this one, and from that we got the value of area. A minimum was 31.214 meter square. Okay, so we will proceed with the next question. So next question says a surface water treatment plant operates round the clock with a flow rate of 35 meter cube per minute. So it will be basically meter cube per minute. The water temperature is 15 degrees Celsius and a jar testing indicated an alum dosage of 25 milligram per liter with a flocculation at GT value of 4 into 10 to the power 4, producing optimum results. The alum quantity required for 30 days of operation of the plant is, okay. So in this question basically first we will write the given data. The Q value they have given as 35 meter cube per minute. The water temperature is 15 degrees Celsius. Alum dosage is 25 milligram per liter with a flocculation at a GT value of 4 into 10 to the power producing of the alum quantity required for 30 days in kg operation of the plant is, okay. So in this question, so basically what we do, alum quantity required for 30 days. it will be equal to, see, flow rate they have given in terms of meter cube per minute. So we have to first convert it in terms of meter cube per day. So 35 into 24 are 60 minutes, 60 second. Sorry, not second. This will be only minute. Okay. So first of all, we have calculated in terms of meter cube per day. Okay. So now up till here, it has come in terms of meter cube per day. Now it is in terms of per day. So total number of days is 30 days. It is given in the question. So if so basically this is the total number of days, and LM dosage is 25 milligram per liter. But in answer they are asking in terms of kg. So we will multiply it with the 25 into 10 to power minus 6. So milligram is converted into kg. So the value we will get as 30,000 37,800 kg. Okay. So I hope this is clear. Anyone has any doubt? Is it clear? Am I audible?
Yes, sir, clear.
Okay. So we will proceed to the next question. So the next question says a wastewater stream flow is 2 meter cube per second. Ultimate BOD is 90 milligram per liter is joining a small river. Both water streams get mixed up instantaneously. Cross sectional area of the river is 50 meters square. Assuming the deoxygenation rate constant K dash is equal to 0.25 per day, the BOD of river water is 10 km downstream of the mixing point F. So first of all, in this question we will write the given data. QS is equals to 2 meter cube per second. Okay. BOD ultimate of wastewater stream is 90 milligram per liter. So BOD of river is BOD of ultimate BOD of river is 5 milligram per liter, and flow rate of river is 12 meter cube per second. So from this we will first calculate the ultimate BOD mix. So BOD ultimate of mix. So since one wastewater stream and one joining a small river. So basically BOD ultimate of that mixing point we will calculate as BOD ultimate of wastewater stream into flow of wastewater stream plus BOD ultimate of river into Q river into wastewater stream plus Q1 addition of flow rate. Okay. So now BOD of the ultimate wastewater is 90. Flow rate of the stream is 2 plus BOD ultimate of the river is 12 meter cube. BOD BOD ultimate is 5 and flow rate is 12. So basically 5 into 12 divided by 2 plus 12. So we will get a 240 by 12, 240 by 14. So if we write, we can write 120 by 7 milligram per liter. Okay. So this is the BOD ultimate mix. So BOD ultimate mix. Now knowing the BOD ultimate mix, so in the next we will calculate the flow velocity. So velocity of river flow. So velocity of river flow is basically Q by A, because we know Q is equals to AV. Using that Q is equals to Q by A. Okay. Now Q will be, since so Q will be basically 2 plus 12, because because both the water, so basically this is a river and here is the, so this wastewater stream is joining the river, so here the flow rate will be 2 plus 12 and area of cross section is given in the question. So cross section area of the river is 50 meters square, so here it is 50. Okay, so it will come out to be 0.28 meter per second, so velocity of river flow. Now once we know the velocity of river flow, we will calculate the time. So for 10 kilometer downstream of the mixing point, that what is the time taken to cover 10 kilometer. So time taken to cover 10 kilometer distance. So time taken to cover distance will be, so distance by speed, distance by velocity basically. Normal distance is equal to speed into time. So from that, time is equal to distance by velocity. So distance is 10 kilometer. So 10 into 1000 meter, and its velocity is 0.28. So we got value as 35714.28. So this will be in terms of second, because here it is in meter and here it is in meter per second. So the time taken to cover will come in unit will be second, 35714.28 seconds. So now, so basically time taken value came out to be in terms of 35714.2857 second. So to convert in terms of day, we will get as 0.41336 days. Okay, till now it is clear. So from now, here we will calculate the BOD at time t, L naught, organic matter time t. L naught is equal to L naught, LT is equal to L naught e raised to 1 minus KT. So the L naught value is 120 by 7, which we calculated this one, BOD ultimate at mix, into E. K value they have given as 0.25 in the question. Here it is minus 0.25, and time in days it is, we have just now calculated 0.4136. So LT will come out to be 15.46 milligram per liter. Now we have to calculate the BOD. So now BOD at 10 kilometer downstream, it will be L naught minus LT. L naught came out to be 120 by 7 and LT just now we calculated, it is 15.46. So the answer will come out 1.68 milligram per liter. So answer option A is correct. Is this question is clear? Anyone have any doubt? So basically I will again summarize this question. So in this question they are saying one is wastewater stream, it is joining a small river. Okay, so both the water gets mixed up instantaneously. The cross sectional area of river they have mentioned. So they are asking what will be the BOD of the river water at the 10 kilometer of the downstream of the mixing point. So suppose it is a river. So this is a wastewater is coming. Here is the river water. So from here, what will be the 10-kilometer distance at the downstream? What will be the BOD here? Okay, so a wastewater both stream. So now what we did, we first calculated the BOD mix, that is BOD ultimate at the mixing point. using the values given in the question. Flow rate is given, BOD of the waste stream is given, and the river, small river flow and ultimate BOD is given. Using that, we calculated the BOD mix. Once we calculated this BOD mix, we calculated the, so series wise, this is the first thing we calculated. Second thing, we calculated the velocity of the flow. So here, while calculating the velocity of flow, we considered the flow of the river as well as the waste stream. That is what 2 plus 12 divided by 50 is the cross section area. So now this is the second thing we calculated. Then we calculated the third thing, which is the time taken to cover the 10 kilometer distance. As we know, distance time taken is equals to distance velocity. We use the velocity which we calculated here to calculate the time taken. Now we got the value in terms of second. We converted in terms of days. Then we calculated the LT. After calculating the LT, we calculate the value of BOD at 10 km downstream, that is L0 minus LT. 120 by 7 minus 15.46 gives the BOD as 1.68 milligram per liter. Okay. Now this is GATE 2022 question and it came in set 2. So basically in this question they are asking, in a solid waste handling facility, moisture content of food waste, paper waste and glass waste were found to be MCF, MCP and MCG respectively. So basically they are denoting these food, paper waste, glass and moisture content in these terms, MCF, MCP and MCG. Similarly, the energy content of plastic waste, food waste and glass waste were found to be ECPP, ECF and ECG. Okay. So which one of the following statement is correct? So in this, first what we have to do, I will tell you the characteristics, then we will solve this. So basically components and moisture percentage. Okay. So first is food waste. Food waste moisture percentage 70%. It is better you just know these values. Second, paper 6%. Third is plastic 2%. Fourth is rubber. Fifth is wood. Sixth is glass. So rubber percentage is 2%. Wood is 20 and glass is 2%. Okay. So basically food waste moisture content is 70, paper is 6, plastic is 2, rubber is 2, wood is 20 and glass is 2%. So now knowing the moisture content, we can now first of all we can see which is the correct option. So based on the moisture content, so if you look, the food waste is higher, okay, followed by paper. So in the question they are talking about the paper waste also, followed by paper waste, then glass. Okay. So so this sequence is in, if it talks in terms of moisture content. So looking at that, option A is correct for moisture content. Okay. Now for energy content, we have to look at values of the energy. So similarly, for energy content, so the component, okay. So for food waste, paper, plastic and glass. So for food waste, it is near to 4652. For paper, it is 16747. For plastic, it is 32564, and it is for glass is 139 kg per kilojoule. Okay. Now in this, if you look at, plastic waste has higher, so plastic waste is higher, then paper, then food waste. Okay, so now, so looking at that trend, so option B is correct. Okay, so plastic waste is higher, then food waste. Okay, so if you look at food waste, okay, plastic waste is higher, then it is glass. So plastic waste is higher, then food waste, and then glass. So if you see the trend, option A and option B are correct answers. Okay, I hope this is clear. Is it clear?
Yes, sir, clear.
Okay. So I will suggest you to at least remember these values. It will be helpful for you. Now the last question. The last question says 100 milligram of HNO3 nitric acid, strong acid is added to water, bringing the final volume to 1 liter. Consider the atomic weight of hydrogen, nitrogen and oxygen as 1 gram per mole, 14 gram per mole and 16 gram per mole respectively. The final pH of this water is. Ignore the dissociation of water. Okay. So in this, they want to know, the question asks about the final pH. So we know when HNO3 in water splits into H plus ion plus NO3 minus. Okay. So now you can see 1 mole of HNO3 produces 1 mole of HNO plus ion. So from the equation we can infer 1 mole of HNO3 produces 1 mole of H plus ion. Okay, looking at the mass balance, 1 mole 1 mole. Okay, the second thing is, if we know the total mole of HNO3, that means that much mole of H plus ion has been produced. So we will calculate the mole of HNO3. Mole of HNO3 is equals to given weight. Given weight is 100 milligram. So we will convert in terms of gram, and by molecular weight, molecular weight 1, 14 plus 48. So this is mole. So we will get 1.587 into 10 to the minus 3 mole. Okay. So now this much mole of HNO3. So in based uh, from the equation chemical reaction, we can see 1 mole of HNO3 produces 1 mole of H plus. So obviously this much mole of HNO3 will produce this much mole of H plus ion. Okay. So therefore, if we have to calculate the pH, pH is equals to minus log of H plus ion. So basically, this is the this much mole. If 1 mole produces 1 mole of H plus ion, so this much mole of HNO3 will produce this much mole of H plus ion. So log 1.587 10 to the minus 3. Okay. So the value will come out to be 2.8. So basically the pH will be 2.8. So in this question, option A is correct answer. So is this question is clear? Anyone has any doubt till now? So I will again explain this. So in this question they are asking 100 milligram HNO3 added to water, bringing the final volume to 1 liter. So final pH they are asking. So basically from the equation we can see HNO3 once split produces H plus ion and NO3 minus ion. So HNO3, so since it is 1 mole of HNO3 produces 1 mole of H plus ion, so knowing the total mole of HNO3 will produce this much mole of H plus ions. So that's why we did pH is equals to minus log of H plus ion minus log 1.587 to 10 to minus 3, and we got pH is equals to 2.8. Okay. Yes, Binoy.
Sir, in the previous question, how do
Hmm.
we decide that it is BOD remaining is asked or BOD that has been consumed?
So when nothing has been mentioned, so in this question, right, 10 kilometer downstream.
Yes,
So
sir.
see, in this they have not mentioned specifically BOD consumed or BOD remaining, right? So whenever there is no such thing they have mentioned, we will follow this method only. In question, in few question of gate, they will specifically mention. Okay?
Okay, sir.
Yeah. Anyone else has anything to ask? So this is for today's class. If anyone have anything to ask till now, you can ask. I will be here till 4 o'clock. Also, if anyone wants that other topic which I can discuss in the next class, you can also suggest. So if none of you has any doubt, I will request you to please leave the class. Yeah, welcome.